Okay, the next thing we're going to have a look at is the shape of a distribution. Now, we have talked somewhat about this before, but a distribution gets its shape by when we draw a polygon of its frequency. So if I was to do lots and lots of dots, I could have a dot plot. Let's say I have a dot plot that looks like that, and I could draw a shape around it. Essentially, that's what I'm doing by drawing a polygon, because I'm simply just plotting the points. Most of the time, in the past, what we've done is draw the histogram, put the points on, and join them up with a polygon. But of course, I could just plot the points. If these were the scores down here, and this was my frequency, so if that occurred 4 times, 6, and maybe that's 1, then I could draw my frequency like that. So if I am essentially looking at the frequency polygon, so frequency, how many times things are occurring, then I'm looking at the graph or the shape of this graph, and it can tell me things about the different types of statistics or the scores that I've included. So if my graph is symmetrical, so it's looking like, it could look like that, or it could look like this. Okay, essentially down the centre, what I can see that occurs in exactly that same spot is the mode, the score that occurs the most. Obviously, the highest frequency is sitting at the top there. When it's symmetrical, the thing that also occurs at exactly the same spot is the mean, or X bar. And just when it's symmetrical, remember this is the score and these are the frequencies. Also what occurs at exactly that same spot is the median. Because if this is symmetrical, then exactly half sits on this side and exactly half sits on that side. So the score that occurs the most is directly in the centre of that hump, and it's also the score that is directly in the middle. It also happens to be the score that is the average. So that's what we look at for a symmetrical set of data. Now, what if the data is not symmetrical? Then if the data is not symmetrical, it's one of 2 other things. So it can look somewhat like this, or somewhat like this. Okay, this is what we call a positively skewed. Okay, this is what we call a negative skew. If you think of the word skew like a dog's tail. If a dog's wagging its tail, pointing its tail out straight, it basically gives you an indication as to what the dog's emotion is at that particular time. So if you wanted to see and you walked up to a dog and it had its tail pointed straight out, you would probably have an indication that that dog was looking pretty cranky at the point. So if I look at the skew, I'm looking for the tail. So if this tail is in the positive side, then it's a positive skew. If this tail is in the negative side, so obviously positive is up here, negative is down here. So if the tail is negative, then it's a negative skew. And what that means is that up here is where most of the data, and up here is where most of the data is sitting. So what generally happens is at the very top of this point is obviously my mode. That's the score that occurs the most. So at the very top of that point is my mode. Now because I have not so many, but I do have some scores that are occurring down here and up here, it's going to affect my mean. So that means my mean is going to be, in this case, I have scores on this side, so my mean is going to be sitting on this side of my mode. Because I have scores down here that are a lot lower than the majority of where my scores are sitting, my mean is going to sit on this side. Now the median is the score that sits in the middle. So if my mode is sitting right at the top of that point, then my median is generally going to be in between my mode and my mean. So it's obviously sitting in the middle. Now remember, the top of that hump, up here when it was symmetrical, was the mean, the mode, and the median. But the top of this hump, when it is skewed, is my mode. My median sits in between my mode and my mean always sits on the skewed side, because that's where I have scores that are greatly different to the majority here. So they are either a lot bigger or a lot smaller. So what I do when I do my mean, mode and median as to where they've got to occur, my mode always goes first. It's where the top of the hump is. My mean is on either the left or the right hand side, depending on where the skew or the tail is. And my median simply sits in between the two. If I wanted to have a look at an example of this, I could either do a dot plot, as I said, I could look at a histogram, I could also look at a stem and leaf plot. So if I have a stem and leaf plot that might have numbers over here, say 3, 4, 5, 6, I can then draw a shape around my stem and leaf plot as well. So basically I can either state, is my data negatively skewed, is my data positively skewed? Do I have some peaks in my data? So does it peak up and peak back down? So does it do something like that? Or of course it's not going to be straight up and down, but does it have something like some sort of series of mountains in it? Do I have clusters of scores? So do I have a reasonably symmetrical, but then my cluster sits in a particular spot? So if I was looking at this example here, I might have a cluster here and a cluster here. So I might also say I have a peak, but if I had a series of other scores that were occurring at this point, then I would have a cluster. So a peak generally if there's just one score, but a cluster if there's a couple of scores that are occurring high and a couple of scores that are occurring high somewhere else. I could also say that it has no clusters, that it has more than one mode, or it only has one mode, and again that it could be symmetrical. So I think that's more than enough information for you now to be able to work on exercise 4.03, and all it's looking at is getting you to describe the shape and state the number of peaks that exist. So it's fairly straightforward. It gives you some examples, and it tells you the first one gives you the positively skewed with a cluster around 6, negatively skewed with one mode. So it gives you some examples of the sorts of language that you need to use when you're describing. So you can work on question 1 through to question 7, and on the PDF that's page 125.